Along with the other lectures on how to do various things in SPSS, I would strongly encourage you to download this and have it as a accessible source for future research and also for future classes, just so that you have these walkthroughs available. So this is going to be a fairly short one. We're really talking about what we need to do if we're actually using SPSS to convert an interval scale, so a continuous scale, into a categorical dichotomous IV. So this might be, for example, if you've got something that's scored on a 0 to 100 and you want to divide it into A, B, C, D, or F. So you're wanting to convert it from the original raw scores into something more categorical. More often than not, it might be basically dividing a measure or a score on an outcome into a pass-fail, so two categories. Either way, we can use this technique to do this, and we're going to walk through this. It's a little more complex, and generally we'd be doing this to a collapsed score. So thinking back to the other SPSS walkthroughs where we talk about how to create a mean or a sum, in other words, how to calculate a combined score. That combined score is what we would often then convert into a categorical dichotomous IV if that's what we were actually needing it to do. So let's take a look at what we can do with that and how we can do it in SPSS. So this is, again, continuous data to our dichotomous data. So first, you want to identify the mean of your continuous scale variable. So note reverse scoring, internal consistency, and compute variables should already be completed prior to these steps. Now, I'm going to be specifically using the mean. In other words, what I'm going to be using as my example is taking a continuous variable, and we're basically just dividing it into high or low based on the mean score. I just want you to recognize that if you're doing this, you'd take the exact same steps if you were wanting to divide this into top 25% or bottom 75%, or if you were wanting to divide it into multiple categories. Or it may be that there's a cut score. So the test itself is on a 0 to 40 scale, and anything over a 35 is considered passing. So that 35 would then take the place of the mean. But in this case, we're basically just going to do a high-low examination. So the first thing we need to do is find out what the mean is of our sample. So we go to descriptive statistics, descriptives. Once there, we bring over the variable that's currently in a continuous form in order to transform it into to get the mean. So we're going to click our variable, click the arrow, and once it's over there, we're going to click OK. We're going to get this readout, and it's include the scale mean. So in this case, the midpoint of our scale is a mean of 2.0155. Generally speaking, we can definitely round this if we want, but it usually makes more sense for us to actually use the full value given, simply because it's much less likely that anyone has that particular score. So now that we've got that mean, we need to actually calculate the new variable. So we're going to go to transform commute variable. Click on that, and that's going to take us to this scale. So we're going to name your new two-level variable. So in this case, it's going to be IV2 levels, for example. You can name it just about anything else that you wanted. It's up to you what you name it. Just remember, SPSS doesn't like spaces or special characters. Now we're going to type a 1 to define our first level of the IV. So basically, what does a 1 stand for? And this is where we could also be doing more than just splitting the data in half. We could have it in quartiles. For example, top 1, 2, 3, and 4. We could have A, B, C, D, E. But remember that for SPSS, we're still going to have to assign numbers. So if we're wanting, for example, to do a grade, we'd have to have 1 representing A, 2 representing B, etc. So once we have that 1 in, the first number that we're going to be doing the division by, we're going to click if. Then we're going to click this button, include, the case is if. We're going to choose our continuous variable, the one you got the mean from. Again, we're going to click the arrow, and we're going to click continue. So notice we're writing out a less than the mean of the scale. So this is telling SPSS that for this particular item, the new variable will be 1 if it's below the mean of 2.0155. Now again, if this was, you were calculating A, so basically 90% above, you could put the test score less than, or in this case, greater than 0.90 or 0.89999. Whatever it is that you're wanting to divide the data by is going to go in here. In this case, though, with this example, making it simple, it's just going to be the mean. We're going to click continue. That's going to take us back to this table, and This will create a new variable with all the people who scored under the mean listed as 1. We're going to click OK. Now we've just created a variable that has basically only ones in it. So we're going to start all over. We're going to hit compute variable again. Once again, we're going to make sure the name is the same. Do not change this because we're wanting to basically just add to it. We're going to now write a 2. We're going to click if again. And in this case, we're going to change less than to greater than 2.0155. We're going to click continue. We're going to click OK. This will code the already created new variable with all the people who scored over the mean listed as 2. Once again, it's going to ask us, are we wanting to change the existing variable? In this case, the answer is yes. And we're going to find that we now have a new variable where everyone that was above the mean is listed as a 2, everyone below the mean is a 1. Now again, like I said, you can use this exact technique to turn any continuous variable into any number of categories depending on what's driving you. This is simply an example of high and low based on the mean, so above the mean or below the mean. It could again be an arbitrary score, it could be a cut score, or you could be doing, for example, 90% and above, 80% and above, 70% and above, 60% above, below 60. Whatever you're wanting to do with that original variable, you can use this function to do that. Just as a final reminder, whenever you're presenting anything in APA format, the stats do need to be presented, and generally what it is going to be is the stat name first, the degrees of freedom, whatever it is appropriate for that stat, the actual value of the statistic, whether it's significant or not. So P, again, we're looking generally for below 0.04 or 0.05, sorry. And if it is significant, the effect size. So this is an example of an F or an ANOVA in APA style. But it would be the same for a t-test or a correlation. If it was a correlation, it would simply be R. There'd be a single degrees of freedom, n minus 2, the number of people that you actually looked at minus 2, the value, the p-factor, and instead of partial eta squared, which is for ANOVA, it'd be your R squared. All stats need to have effect sizes presented. If you do present Levene statistic, you usually don't have to present an effect size. And some people would argue that if it's not significant, you shouldn't report an effect size. But also just a quick reminder, whenever we're presenting test information, any of the test statistic abbreviations are italicized, whether it's a T, an F, an R, an R squared, a D, a mean, a standard deviation, whatever that is, that should be italicized. So hopefully this will provide you a nice little ability to go in and modify your data even further if that's what you're needing to do.